If you would like to learn about rocks, you have come to the right place. Year 8 Earth Science. We can see that there's a few different rocks that we're looking at now. That's from the Pinnacles in Western Australia. This is interesting. That's the jaw of a giant wombat, and we can see that the teeth are still intact, so that's an original fossil. That's basically what it was when it was buried. This one's in Hawaii, and in Hawaii at the big volcano the lava actually makes it all the way down the hill to the ocean. There's lots of lava tubes and stuff it goes through, and it actually vaporizes the water when it hits it. It's pretty cool, very explosive. We've got some iron ore. That's from the Pilbara in Western Australia. Here's a rock. That's called conglomerate. This one's pretty interesting. It's called orbicular granite. So orbs, these little orbs, they're actually 3D spheres, and that happens in a granite. It's not mineralization. It's pretty cool. And there's some obsidian. So that's very, very fast cooling lava. So our curriculum outcomes. There is a link to this in the description. The link straight to that. If you want to have a look at that. But really what we're doing is we're looking at rock types, we're looking at how each of the rock types form, we're looking at the relationship between the rock types, what role does weathering and erosion play, what role does heat and pressure play, rocks are made of minerals, what is a mineral, so what is a rock? So it's some criteria that rocks need to be to meet. They have to be a solid that occurs naturally and made up of minerals or mineral-like matter. Okay, we've got 3 rocks here. That one's a schist. That's a bit of granite close up. It's been cut as well. And this is a rock called breccia. We can see that it's kind of like one particular type of rock has just been smashed up and then cemented in by this mineral here. And that's pretty much what's happened. So this one's coal, and this is coquina, and we can see that this is not made up necessarily of minerals, even though this seashell technically is calcium carbonate, and most of what's in here is little smashed up seashells. Coal is made from peat, and peat is decaying plants pretty much. When they get cooked a little bit and compressed, they form coal. So technically it's not minerals, but mineral-like, so that's coal and coquina there. So a mineral, these are the criteria that it has to meet. So it's got to be naturally occurring, has to be a solid at room temperature, is inorganic, again, mostly, can be made of one element, but it's usually made from many, so usually a compound, and it has an orderly crystal structure. We can see this bit of quartz up here. They're all solids. This bit of quartz up here has a particular crystal structure. It's hard to see from that. Down here, this bit of pyrite, certainly we can see that grows in little cubes. And we can see there's a crystal structure in here inside this agate. You might have heard them called thunder eggs. And this was pyrite, and they grow in twins, so they grow into each other just like this. That's one twin. What's happened there is that the pyrite's been replaced by geothite, another mineral, but the geothite's taken the shape of the pyrite in the rock as the pyrite's disappeared. So if you want to look at this video, that's the dazzling minerals behind modern life. So you can pause it and go and look, it's in the description. That's just pretty cool. Silverstein, that's a mineral. It's in here pretty much because a few years ago, one of my students was called Celestine. She already knew, so that kind of spoiled the surprise, but I think she was pretty happy. So we have some definite structures here. So that's calcite. It's kind of that parallelogram structure. So here's smoky quartz. Now that's just quartz with, I don't know what element there's in there, but it'd be a little bit, so it's not pure quartz. There's some contamination essentially from another atom sitting in particular spots, replacing the silicon. This is fluorite, and that grows like 2 pyramids on top of each other. So this is chalcopyrite. Has that goldy colour. It's called fool's gold. This is some basalt, and it's got olivine in it, and peridotite. And here we can see another crystal structure I can't remember what mineral that is. So rock types, we have 3 rock types, and it's to do with how they form. We have igneous, sedimentary, and metamorphic rocks, and they do change. A metamorphic rock can become either of the other two, sedimentary rock can become either of the other two, igneous, etc. So the rock cycle video, so that is the next link, and it's the Michael Samaranto's rock cycle video. So have a look at that now, and then come back. So what we can see here, sometimes kids don't like this one because it looks complicated, but this is the reality of what happens. Extrusive igneous rocks come out of a volcano. Weathering and erosion occurs. So weathering is a breakdown of rock, erosion is when it's taken away. Transport and deposition, sediment. So the smaller particles make their way to a water body and they all settle down the bottom. With compaction and cementation, they're going to turn into sedimentary rock. So you've got that sediment and you need to compact it and a little bit of heat, squash it together, and it'll cement in to form sedimentary rocks like sandstone or shale. But if the temperatures and pressures get high enough, we're going to get metamorphic rocks. Any one of these rocks could melt and they could go into magma again, and then what would happen is they could become an extrusive igneous rock, or if the magma doesn't reach the surface, we call it an intrusive one. And the magma's can be coming from the crust or the mantle. For instance, over here could melt if it gets hot enough. Around this magma is going to get pretty hot, that might melt. Or it just might become metamorphic rock. It's a nice little ring around the heat source. Here it is in a simplified version. We can see it's a glorified flowchart really. We've got the rock types here. Magma's up there, sediment is down there because they play an important part in the process. So sediment comes from the weathering and erosion of any of the 3 rock types. Igneous rock comes from magma, which comes from the melting of any of the 3 rock types. Metamorphic rock comes from heat and pressure, as long as there's enough, from any of the other rock types, including itself. So you can have a metamorphic rock that is low grade and it becomes a higher grade of metamorphic rock. We'll look at that soon enough. Weathering and erosion. So we can see there's a few processes here. So they're different. So we're going to get to that. We can see that weathering is occurring here, and the sand and stuff on the ground, that's erosion. So weathering is the breakdown, erosion is the taking away. So this is an example. There'd be some weathering going on, but erosion probably at the same time. So it's picking up all little particles and sending them down the waterfall. We can see the weathering occurring here. This is at Kalbarri. And we can see there's an amount of erosion, like this swell coming in is going to break up this rock and then take it out to sea. And we can sort of see over here sandy sort of particles under the water. So this is weathering. Some of you may have seen that up on Castle Rock. That's actually joined at the bottom, so it's not balanced there. So it's called spheroidal weathering, and it's weathering around and around and around. Eventually, if it gets all the way in under there, this rock will fall. We can see that there's been weathering coming down in a perfect straight line. It's quite cold up there during winter. What's probably happening is there was a crack formed, and then water kept getting into the crack. And as water gets in the crack and freezes, it expands, just making the crack a little bit bigger, till eventually that bit of rock sheared away. So it's so straight because that's the direction the water's going to go, and when it gets in the crack, it's going to go straight down. So here's some interesting weathering. We've got a tree growing out of a big boulder. We can see that its roots are powerful enough, getting in little cracks, and it's just breaking up the rock. So weathering's a breaking down of rock, and there's 2 types of weathering. You've got chemical or physical weathering. So chemical weathering happens because of chemicals. So quite often it's just gases from the atmosphere and water making a weak acid, and that weak acid over time is going to be able to dissolve minerals in the rock, breaking it apart. So really weak acid. It takes forever, but it happens. Happens more in hot, humid locations. So like at the equator in the tropics, you got a lot more chemical weathering. Physical weathering is another way of doing it, and so water, ice, and wind. Basically, just we're talking about smashing stuff apart, and plants and animals will do physical weathering as well. So the physical breaking up of rocks. Now, water, ice and wind certainly in the lower latitudes do the majority of the weathering, whereas chemical tends to happen near the equator. So here's some examples of things that can result in physical weathering. You can read that list. Probably the coolest one's glaciers. So when you form a glacier up a hill, well, a glacier is like a river of ice and it flows down the hill. And what happens is, as it's flowing down the hill, because it's enormously heavy, it can be kilometres thick back in the good old days, and so it's doing a lot of scratching as it goes down the hill, and it basically takes whatever rock it interacts with as it goes. Erosion. So it's the removal of that weathered rock. We can see here's a glacier that's probably hundreds of metres high. We can see that it's actually flowing down here, and this is the front of the glacier. When it gets to water, it sort of melts and breaks off and can form icebergs, things like that. So we can see it's flowing downhill, and that might go at a metre a day or something like that as it goes. This is an example of something called a drop stone. Now, this boulder here doesn't belong in this shale that it's located in. The only way a boulder like that can get into a shale is basically if a glaciers brought it down. So if we see these things called drop stones, we know that at some stage in the past there was a glacier. So it means wherever you are, it was pretty bloody cold. We can sample this rock and we can get an approximate date for it. And then when we've got that approximate date, we've got a good idea of either what the conditions were on Earth at the time, or where this particular bit of rock lived. Was it at the tropics? Was it near the South Pole, for instance? If there's evidence of glaciers, it's a good idea to think that it would be near the South Pole rather than the tropics. But if it was at the tropics, that's telling us that there were glaciers at the tropics. Pretty unusual conditions. Evidence of a climate change. Okay, so the agents of erosion: wind, water and ice. Now, wind, water and ice also weather rock. Okay, don't get confused. When you hear the term agents of erosion, it is referring to these three. Okay, that's the only way well, I guess animals could bloody pick it up and carry it, but that's compared to what wind, water and ice are doing, it's completely insignificant. So these are the three things that are essentially doing erosion. Wind can carry small particles, water can carry bigger particles, and glaciers can carry mountain-sized particles. When the glaciers, like if it's kilometres thick, it's going to carry ridiculous amounts of matter. So here's evidence of a glacier at Kosciuszko National Park. Just up the hill from here is a place called Blue Lake. We can see there's a pond here, and then we can see there's a row of rocks that have made a little hill. Row of rocks here. We can see rows of rocks pushed to the side. So down here we can see the further. So these are called moraines. And what happens is the glacier takes it down there, and that's the point where it melts, and so it dumps everything that's picked up on the way. And then we can see lines coming back. If another glacier comes and it goes all the way down to the bottom, it's going to pick up all of this stuff. And we can see that there is actually lines quite fair way down the bottom. Because they've been there longer, it's been more time for soil to be produced. Now, so this is Kosciuszko's like over to the right. It takes a long time for weathering or for soil creation in the alpine regions, simply because, see, there's no trees. There's only trees on that side because they're protected from the wind. On this side of the mountain, there's no trees. So wind and sunlight are the things that are going to prevent trees forming. And it's pretty cold when you get up there.